Hola, Sia, Ole, Namaste, Salam, Marhaba, Namaskar. Hello, friends. Today we are going to start with our topic control system, and today I am going to give the introduction part of it. So, let's take any system, and if you give an input to that system, we have to get the controlled output of that system, and this whole thing will be studied in control system. So first let us consider the definition of it, which is control system is that means by which any quantity of interest is maintained or altered according to a desired manner. Control system is that means of which by any quantity of interest which we need is maintained, and that we maintain, that can be altered also according to our desired manner. This sounds kind of difficult, but I am considering an example which will make this thing easy. Let us consider an AC, and let's think that the temperature of our environment is near about 50 degree or 45 degrees, so it is quite too hot. So we have to maintain the temperature at around 16 degree or 20 degree, which is bearable, and in that case we are the sensor or controller. We will be giving our feedback, and according to that the system will maintain the 16 degree or 20 degree temperature, and this is working as a control system, right? So our interest is 16 degree or 20 degree, that is maintained by the system, and we can alter the temperature if we want 16 degree or 18 degree or 19 degree or 20 degree. We can alter that using remote, and we can alter the temperature. Now let's take a block diagram for that. Let's take a block diagram where it is very simple. We are giving the command to the controller, and a signal is going to the plant, and the plant is giving the controlled output. We can consider another example too, where the plant is car and controller is steering, right? And we can say it with our regular day example. We use car, we use AC, and this is easy to understand. Now every time there is a disturbance, or we can call it a noise or something like disturbance is easy to understand. There is a disturbance to the system, then the output will be undesired, or an undesired output. Hence in that case we find out the error detection, and by giving the feedback with a sensor we maintain the output. Hence the practical control system block diagram will look like this. A command is given, a controller is there, a plant is there, a control output is being represented, but there is a feedback path, right? There is a feedback path. Feedback path is drawn like this, you know. There is a sensor or feedback element. There is a sensor or feedback element which is giving the feedback signal. Let's BT, and the error is being detected here. The command is going, the feedback signal is going here, and the difference or the error is going to the controller, and controller is giving the actuating signal. The actuating signal and the plant is then giving the controlled output. So the objective of any control system is to ensure that controlled output becomes same as desired output. The state is called set state, but if any disturbance takes place, any disturbance takes place, controlled output differs from the set value. In order to restore the controlled output to its original value, control system is modified like this. The control system is modified like this. Now now we have to talk about the feedback, and I'll prepare another video for this feedback. Now now let's study about the systems. There are two types of control systems. There are two types of control systems. There are two types of control system. Types of control systems. Control system is of two types. One is open loop control system, and another is closed loop control system. One is open loop control system, means there is no any loop. You are giving an input to a system and you are getting the output, but there is no any feedback path. But in closed loop control system, there is a loop. There is a loop. System, output, input, and there is a loop which is actually for feedback, and the feedback can be of two types. One is positive feedback and another is negative feedback. One is positive feedback, another is negative feedback. So now let us talk about the differences between open loop control system and closed loop control system. By this you will understand it easily. Now, the behavior of open loop control system does not change, though its output changes. Hence, open loop system is not accurate. The behavior of open loop control system does not change, though its output changes. Hence, not accurate. You can understand this point easily through this block diagram where there is only input and output and there is no feedback, right? Because there is no feedback. In case of control system, the behavior of control system changes if its output changes, because there is a path feedback which we are taking from the output side. The behavior of closed loop control system changes if its output changes. Hence, closed loop system is accurate. Now, open loop system has no sense, but it may have sensor. Open loop system has no sense, right? We can understand it from the first point, but it may have sensor. You can attach any sensor to it. Has no sense, but closed loop system has sense, and that is either manually or automatically. Closed loop system always has sense, either manually or automatically. This is a very important point. You can remember this point. This is very important. I am writing it here. Now, the very important point, which is about time constant. Time constant of open loop control system is large, due to which transients takes large time to die out. Hence, open loop system is slow. Time constant of open loop control system is very large. Is very large means the transients take large time to die out. Hence, open loop system is slow. The time constant of closed loop system, this is open loop, of closed loop system is small. Hence, transients die out rapidly. Hence, closed loop system is fast. This is a very important point. Open loop system is simple and economical. Simple and economical, and obviously closed loop system is expensive. Now, very important point, remember this: open loop system is generally stable but cannot be stabilized if becomes unstable. Open loop system is generally stable but cannot be stabilized. Obviously, you can understand why. Cannot be stabilized if becomes unstable. But closed loop system can become unstable, but can be stabilized, because we can take the help of feedback and it will help us to stabilize the system. Now I'll talk about some point which is related to feedback. I'll describe all the points in my next video where I'll talk about the feedback. So there is two types of feedback. One is negative